Any sufficiently advanced technology is indistinguishable from magic.
So for the next session, we got Jordan, originally from the US. He now lives in Portugal. He's the world traveler, and he stopped in Bulgaria to talk about AI, right?
That's right.
There you go. So give a big round of applause for Jordan.
Hello. You guys all doing well? I'm assuming you're doing well. I mean, you had your coffee. Look, if I can't sleep, all right, you guys can't sleep. All right, so what are we talking about today? We're going to be talking about how to build really the pieces of a spam detection bot. In fact, the example I went with in the end is not completely a spam detection bot, but, or I should say spam detection mechanism, but it is actually the same way that Gmail works and all these other things work. And so you may be wondering, why even do data science in Excel? Why even do AI in Excel? Because what we're going to do today is a little different than what we typically do, or at least what you've seen today. So most of us understand AI as the end product, all right? Someone gives us a component, in this case, let's say Copilot. Let's say it's something you can drop into Power BI, and it really does the work for us. So we really need to just understand, what is it you want to put inside of it? In this case, we're going to actually build the data science model in Excel so you can see how it's done. And the reason that you might want to do this, like, I'm just going to be real, I don't know if I would really do this out in production, but one reason you might want to do this in Excel is because as analysts, even if we're not going to be data scientists, on the one hand, we need to know less and less about the guts because we're getting these completed projects. On the other hand, that work bleeds over into what we do, so we need to understand what these inputs are, and we do need to have an understanding of how it works behind the scenes. And then the other thing is, and I know Oz hates this. No, you'll like this. I mean, you'll like that you hate this. So if you go on LinkedIn right now, and you will see lots of posts that say RIP Excel, right? You know, Excel is dead, Excel is over. What I want to show you here is that, in fact, this is not the case, that you can actually do a lot of these types of things in Excel if you think through the problems correctly. So even if you never end up building a spam detection mechanism, what I'm going to show you here is actually fairly useful if you have to classify documents. Let's say you need to go through tons of documents and you want to know, is it this type or that type? Want to help yourself out. And then, you know, the other thing is that, actually, I'm just going to work into that point as I keep going. So we're gonna talk about how to build our spam detector in Excel. So why Excel? You know, why not? I mean, that's my first argument for everything. It's a great place for explanation. I want you to get an imagination for the data science work you can do in Office, because Microsoft does have they have this vision, at least in terms of Fabric, where you use Power Query to clean up your data, and then you can run it through some machine learning model. We're not going to do it as a service. We're going to actually do that in Excel. And then I really want you to understand how these algorithms work. So one thing I want to be honest with you about, and I may have some imposter syndrome here, right? So I wrote 2 books. This one over here is my most recent one, Data Smart, and that is, in fact, what we are going to be doing. We're going to do chapter 3 from Data Smart today, and that's how to build it in there. And so these 2 books, I've actually written 4 books, but I'm not including the first 2 because they're less relevant. But the first book, Becoming a Data Head, is really explaining data science and analytics without a whole lot of math. And then the second book is how do you do these things in Excel with some math. And here's the part where I have imposter syndrome. Well, let's say I took linear algebra like 5 times, you know? And I got a C on the last time. And while it is true that it is a bit of a gamble on who your professor is, math is not my first subject. And so the person I wrote Data Head with, one of my friends, he has a PhD in math and stats. So he's always being very technical with me when I say something. So we're going to go into Bayes' theorem here. I'm going to try to do as little bit of math and as little bit of totally thinking about it as possible. But I am afraid someone's going to be like, okay, well, that's technically not true, blah, blah, blah. I want us to just step aside from that because the goal today is to show you how you can build something like this in Excel and just show you how quickly you can do it because it's easy when I do it, but it's an advanced concept. So that's what I want you to focus on and not to get too hung up on the math. All right, so probability. This is, I think most of us understand probability. I was thinking of just writing 1 over n here, you know? Not that that's exactly probability, but I think we all understand that. All right, so independent probabilities you add, dependent probabilities you multiply. What about, more or less, what about conditional probabilities? Okay, well, what do I mean by that? So the Powerball jackpot in the United States, that's a lottery in the United States, to win that lottery, it's 1 in like 292 million to get a ticket, all right? That's the probability of winning. But that probability actually does not describe the whole story, right? Because it's predicated on what? What was it? Not necessarily. I mean, it's really easy here, right? It's obvious. You're going to be like, what, really? It's that you buy a lottery ticket, right? That's it, right? That is an event that has to happen. Well, it doesn't have to happen, but let's just assume that that is an event that is really baked into that probability, okay? What was you bought a lottery ticket, so that probability is given that you bought a lottery ticket. Okay, so that's kind of step 1 in thinking about conditional probabilities and Bayes. Okay, so next up, all right, you're at the drugstore, you buy a COVID test, it says on the front, can 99% accurately predict positive results, okay? So you go home and you take the test, it comes back as positive, all right? So how likely are you to actually have COVID in this case? Well, it can't be 99%, because when it said that probability that was given to us is based off the idea that you actually have COVID. So it's 99% given that you have COVID, right? In this case, in this case, we get the test first, right? We get the positive result first. Let me think how to say this. This is why I always mess this up. Okay, so it's 99% given that you have COVID. What is the likelihood you have COVID given the result, all right? So that inverse is not so clear. We can't say that exactly because, and this is really true with these types of tests, they want to be more sure than not. So in fact, the false positive rate is a lot higher. So these are things that we would be missing. And in addition to that, we'd also want to know, to answer that question, well, what is the rate, like, what is the likelihood of the incidence of COVID within the population you're in? So those two things together would actually give us that result. And this is not an easily intuitive thing to understand. If you've ever seen the movie 21, they talk about the Monty Hall problem. I don't know if you know it, like behind two doors is goats or a car, and then you switch and the probabilities adjust. So this is Bayes. It's not something we're necessarily programmed to understand, but once we get our heads around it, it allows us to do some really interesting stuff with data science. Okay, so this is taken directly from my book, Becoming a Data Head. Here's this problem, all right? Your company is hacked, and 1% of those laptops are infected. You have developed a test that is 99% effective in both directions, so positive and negative. All right, so this is basically just the same problem I set up. Your laptop has tested positive. Given these facts, what is the probability that it's been infected? So 99% accuracy, 1% have been infected. You go up to your laptop, you don't really know, you run the test, comes back positive. What is the probability? 50%. 50%. So that's not necessarily intuitive, but let's take a look at that. And before we go on, I do just want to point out I'm going to pull up my pen here. I do want to point out here that I'm going to be using these notations. So the probability of a positive test given a virus is 99%. Negative test, not a virus, is 99%. And the probability of a virus in general is 1%. Okay, so here's how we map this out in this tree map. And let's say we have 1,000 laptops, okay? So 1% have a virus, that gives us 100 laptops. So we know that 99 of those laptops are likely to test positive. So that has a virus and test positive. So let's go to the no virus one, and we see that because there's an error rate of 1%, another 99 laptops have no virus and test positive. So I'm going to try to explain this a few different ways. This is the way that I like, that my PhD friend does not like. He prefers the math. But the way I like to think about this is there's only 2 test positive outcomes in here, okay? So you're either in the 99 laptops that have a virus and tested positive, or you're in the 99 laptops that don't have a virus but tested positive, okay? Both of those buckets are the same amount, so you can only be in one of them. That's 50%, right? I mean, that's basically it. So that's the way I like to think about it, as not being a pure math person. But just in case you care, here's where we go, okay? So here's Bayes. So what Bayes allows us to do is relate probabilities. So like I said when I was talking about COVID, and I'm just going to try to use my finger here, right? So we know what they claimed to us was the probability of getting a positive result when you have a virus, right, is 99%. But finding the inverse, right, the probability of a virus when you've tested positive, we don't necessarily know what that is, right, because we can't just invert the probabilities except for when we use Bayes. So Bayes allows us, with this formula right here, to actually relate the probabilities to one another. So like I said, probability of A given B multiplied by the probability of B, right, which is if I buy a lottery ticket, or I mean, I am likely to win the lottery more likely, let's say, if I buy the lottery ticket, right? So that's the way we can understand things, and if we have the other terms, we can actually figure out what the answers are. So here's the math way of doing it. I've rewritten it here. So the virus, in this case, the computer virus tested positive. Basically, this one right here, excuse me. So this one right here, the probability of testing positive, that's 1.98%, and that we get from adding up 99 plus 99 laptops, dividing by the 10,000 laptops. That gets us 1.98%. And then the probability of detecting it, if it does in fact have a virus, is 99%, multiplied by the probability of having a virus is 1%. Divide that all, you get 50%. So that's the math behind it. Feel free to clap if you want for math. Wow, I can't believe that worked. All right, so what does this have to do with spam detection? This is how your spam detector in Gmail works. Basically, instead of like having one event happening, the way it works is we have the probability that something's spam given a set of words. So they call this the bag of words model because basically you take all those words that that could potentially be spam, and then you figure out what their frequency is, and that gives you their probability of existing. And then we do the same thing with not spam, right? So the probability of not spam given that same set of words. And this is really how the spam detector works, okay? It says, what is the probability of spam given these set of words? And what's the probability of not spam given the same set of words? And whichever one is greater, it picks. So the thing is, I was talking to you about conditional probabilities here. And this is really interesting because when it comes to words, we don't really know if the probabilities are actually conditional, right? So I live in Portugal, in the way that Portuguese language is structured, someone might say to me in English, always, I get espresso in the morning, right? Where I might say, I always get espresso in the morning. So the way that the words exist in a sentence may or may not be dependent on one another. So what we do in this case, this is called naive Bayes, because even though we treat it like it's all conditional, we don't really care if it is or if it's not. So that gives us a really easy way to understand this problem. So if I was trying to figure out the probability of spam given a certain set of words and also not spam given another set of words, I can use Bayes to actually think through this. But before I do that, I just want to say, excuse me, this is how it's trained. So basically, I have an email subject, right? Advice for mom's birthday. So I know that those contain certain words, and I know that I've labeled it as not spam here. And you can see where it says 1 here. That's just the existence of that word. So in this case, free Viagra, I know that's spam. What words are it's looking for? It's looking for things like free and Viagra. Free stock advice. So you can see that you could actually train a classifier fairly easily because we know that these are spam words. Okay, so this part may seem complicated, but trust me, it's really not. And when we get into it, it really is going to be super easy. So we know, because of Bayes, that the probability of spam given a certain set of words is going to be equal to the probability of those words, given that it's spam, multiplied by the probability that it's spam, divided by the probability of those words. In the same thing, it looks about the same with not spam, except that we just changed the term from spam to not spam. And Just in case you guys notice this, I have already moved this over. This was over here, you know, as part of the multiplication, so I moved it over. So one of the cool things we get with this is that because these have the same divisors, we can just get rid of that, right? So we don't even need to care about that. That cancels out. So we only need to care about the rest of these items here. So again, we don't care if the words are dependent or not. Hence, the procedure is naive. So now I'm going to use an example that I use in the book. It's not quite spam detection. Basically, what we want to find out is, and this is based off of the original example. So DataSmart actually had a first edition written in 2013 by someone who worked at MailChimp. They have an app called Mandrill, so we use their example in the book. So basically, we have a series of tweets, and we want to understand, is this tweet about the Mandrill.com app? So you can imagine some people are talking about Mandrill, the app. Some people are talking about Mandrill, which was a boss in Mega Man, if anyone remembers that. So we want to decipher that. And if we have a set of tweets that we know are about the app, we have a set of tweets that we know are not about the app, we can get the probabilities for each, and then we can run some test tweets through and see how well it classifies. This is how the spam detector works. So we're going to go ahead and do that. So I'm going to open up my completed version first. We'll do the, excuse me. I'm going to walk through this completed version first, and then we're going to redo it. But I just want you to understand how it works. So I'm going to click on About Mandrill. Here are our Mandrill tweets. We know that these are about the app that we're interested in. Then I also have this thing over here about other. Here are other tweets. We know that these are not about what we're interested in. So what we are going to do is we're going to first tokenize our tweets. That means we're going to break every single word out into its own cell. So that's a token, okay, in our bag of words. And then what we're going to do is we're going to take the frequency of the appearance of those words and divide it by the total, and that's going to give us our probability. And then when you run a tweet through, you just look at this bag of words where it, that refers to the app. If it has a greater probability when you sum up those same words that it finds versus the other, that's how you pick. Now, before I get into it, and we're going to have to, we'll hit this again as I go through, don't worry. But I want to point out two things that I'm going to do that may seem a little weird. So the first thing I'm going to do, and I'll get to it when I do it, is what if in our test tweets, the word is not inside our training tweets? So basically, if it can't find that word, it's going to report back a 0 as probability. All those zeros are summed up, so we don't really want to do that. The way we deal with rare words is that we add 1 to everything. So if the word, even if the word doesn't exist within the set, we're going to force it to exist. But that means that we're going to add 1 to every other word to make it fair. So I know that sounds weird. I talk about it more in the book, but you'll just see me do it. Very quick operation. Then the other thing we're going to do is when we deal with really small numbers, when the zeros go out to like 15 digits, Excel does have some problems sometimes approximating what a 0 is, and this has to do with how its engine is built. Most of us will not run into this, except unless you do engineering, but because of that, we're going to take the natural log of it, and I'll show you that if that sounds confusing. Don't worry, I'll just show you that. It's not a big deal. Okay, so now that we've done that, now that we're ready, let's jump in and get started. So I'm going to close the completed version of this, and I'm going to move into the uncompleted version of this, and we're going to walk through it together. And I reserve the right to look at my book and cheat. So, and you'll see that, because we do have some work we have to do in Power Query, which is a pain. So even if you don't get the math, what I want you to follow here today is how I'm using these Excel tools, like tables, like Power Query, because these are things that are actually going to save you a lot of time, whether you use them for automation or whether you use them for AI. And I have to tell this joke. Okay, before I get started. What do Excel users eat for dinner? Lamb, duh. Anyway. They get better. Yeah, clap. Thank you. Thank you. Yes, in the formula bar. That's true. And of course, you know what comes after a good Excel joke? A sequel. All right, so let's do this. I'm gonna hit Control-T to take this set of data and turn it into a table. I'm gonna get rid of the banded rows just because I have class. So, and then I'm going to rename this to About Mandrill, just because it's good to have a well-named table. And then what I'm going to do is I'm going to go to Data from Table Range. We're going to bring this into Power Query. Okay, so basically, you see that we have our series of tweets here. So I need to actually take all of these and make sure I can split them all up into one word for each cell. So many ways to do this. I'm going to show you one of them. And we also need to make them comparable. So I'm going to go, first thing I want to do is under Transform, I'll go to Format and hit lowercase, because I want to make them all lowercase. Makes it easier just to look things up if they're all the same case. So the next thing I'm going to do is, I'm going to just do this real quick. I'm going to keep this, but you'll see why. I'm going to pop this over to the side here like that. And then that's going to allow me to bring up my book over here. And so I'm just going to pop back in here. And because we have to do a series of cleaning steps here, I just want to make sure I get them right. And the reason I did that is it won't stay up like this unless I pop over the Excel desktop first. Even if I open Power Query, it'll get rid of this. Okay, so basically, the things we need to edit and we need to clean up here is we got to remove periods with a space and replace it with a single space, colons with a space, replace that with a single space, and so forth. So I'm going to do that very quickly here. I'll go to the Transform tab, click Replace Values, and here I'll do period plus a space. We're going to replace that with a space. That's our first one. Don't worry, I have a quick way of doing this for our second set. Now we're going to replace colons. Make sure to add a space there. We'll do this again. Question marks. Place that. And you guys know what, this is a joke for me because of like my curls. You know what Excel users put in their hair, right? Some product. All right. We're going to keep going here. So I did that, and I just want to make sure I'm going in the right order here. So I'm going to keep going. We're going to replace the semicolon here. This is not a semicolon with a space. All right. Then we're going to replace the comma, and then we're going to replace the double quote, and then we will be done with that. All right, so I'm going to put that there. Now, there's a chance I didn't do this entirely correctly. That happens sometimes. But I like to go through this because whenever you have a data science problem, then you want to have the results exactly right, that you have in the book. But even if you mess this up a little bit, the concepts are still the same. Okay, so we've done all that. We've removed all the punctuation. So that's going to help us take these words and tokenize them. So the next thing I want to do, and I'll make this bigger here, is I'm going to go to split column, and we're going to do by delimiter, and we're going to split it by a space, and under advanced options, I'm going to say split into rows. So every time it makes a split, it's going to make a new row. I'll go ahead and hit OK on that. Boom. It is split into rows. OK, so the next thing we need to do is we need to get rid of what's called a stop word. A stop word is any word we don't think is really relevant. Now, in the data science packages you could use today if you did R or Python, there are just vast sets that people have put together of stop words. But we're going to use a simple heuristic here. That is this word greater than 3 characters or not? So I'm going to go to Add Column here, and I'll do a custom column. And the formula I'm looking for is text.length to pull out the length like that. So we're going to take the text of the length of the tweet. We're going to hit OK. That gives us our tweet length. And then I can just use my number filters here to say greater than 3. Like that. So that's going to remove all the stop words. Okay, so I don't need this column anymore. I'm going to right-click and hit Remove. So now you can see that we're really honing down on the words we care about. Now, I'm going to do this last piece in here. You don't have to do this in Power Query, but I find that it's very useful to do it in here just to keep things like moving. So I'm going to use the Group By. The Group By button is basically pivot tables in Power Query. So I'm going to group by the tweets. We're going to get the count, and we are going to get the count. We want to get the count of each item in here. So I'll go ahead and click OK here. So that's going to give us the count of all of our items. So I should be good at this point. So I'll hit Close and Load. So we have prepped our About Mandrill. And in fact, I'm going to actually rename this. I'm going to call this About Mandrill Tokens, like that. So we've prepped those. They're good to go. So now we have to do, sadly, we have to do the same thing to the non-mandrill ones, the ones we know that are about the other app. So do I want to go through and just redo all of that? No. So I'm going to show you a quick way to use all those operations we just did on this set of data here. So first step, we'll hit Control-T. This is for our other tokens. I'll hit Enter, get rid of those banded rows, and then I'll call this About Other to keep organized. We'll go to the Data tab. We will bring it into Power Query. So like I said, basically we want everything in this About Mandrill tokens to be done onto About Other too, because we want to compare them. So what I'm going to do here is I'm going to go into About Mandrill tokens. I'll click Advanced Editor. So these are all the steps I took. And so I'm just going to highlight everything up until the change type, because Excel does these ones for us here. So I'm just going to do everything after that. Control-C, we'll hit Done there. I'm going to pop over here to our Advanced Editor for the other one, and then I'm just going to replace this here like that. Let's see here. Add a comma there to let it know. And then one other thing I like to do is whenever you do this sort of thing, you have to remember that M-code is always working on the step that's mentioned, and hopefully it's the last step. So change type was our last step here. That makes sense. That's the one previous to it. So I'll hit Done there. Please work. Oh, it works. Wow, you can clap if you want. Yes, thank you, Power Query. OK, so we've now tokenized our tweets. Again, doing this in Excel, people used to say, oh, you can't do it. But you can. It's not that hard. All right, so we'll hit Close and Load here. And now we are going to use the features of our Excel tables to make our life easier to understand and work with this classifier. So the first thing we need to do is we need to add 1 to everything. So I know I told you that we were going to do that, because that helps us deal when we run our test tweets in here. So I'm going to write add 1 to everything, like that. So I'll say equals here. Again, we love how tables have structured references, so I don't have to think about anything. I just say equals count plus 1. And then, of course, it always fills down, but I don't know what. OK, I don't know. It didn't draw that there. But it looks like it's working. OK, so that we added 1 to everything. So now we want to get the probability of finding these words within this bucket. I'm going to call it a bucket. It's technically called a document, like the list of words, or they call it a bag of words as well. So I'll go into the table here, and I'm going to go to the Data tab. Or no, I'm going to go to the Table Design tab, and I'm going to add a total row. So that's going to give us our total ones here. And I'm going to do that. That was in the About Other. I'm going to do that same thing in the About Mandrill one as well. So we'll say add 1 to everything. Say equals this plus this, OK? Control down takes us all the way down. Go to my Table Design. We are going to add in the total row. So the next thing we want to do is we want to get the probability. So I'm going to go up here. I'm going to say, and I'm going to call this P token given an app. All right. So what's the probability of a token given that it's about the application? So here, it's just dividing a straight line divide. Does that make sense? Straight line divide, a straight division. So I click on this here, add 1 to everything, go all the way down, and then we're going to divide it by the total row. So note, again, all of this is already done for us. So the next thing I want to do here is I said we want to use the natural log, and that's because some of these zeros are really, really low. And so I just want to show you here, if I have a number that has a lot of zeros in it, and I take the natural log of that, it gives us 12. Like, it gives us a more manageable number. Same thing if I have a really large number, it gives us 18. So you can see that it really just compresses it, but this is just a transformation. It doesn't actually change the underlying values, and when we compare, we can either compare the probabilities or the log probabilities. It doesn't matter. So all I need to do here is I can say natural log. I'm just going to name this P of the probability of the token, given that it's about the app. Close that off. And so we're just going to do a natural log of that. And you know, when data scientists go camping, they like to use natural logs. They don't want to burn, fake wood. And so that joke is so silly. But thank you for those who laughed. OK, so we did that on the About Mandrill tokens. We're going to do the same thing over here. So I'm going to say the probability of this case is it's a token given that it's about the other thing. So I'll say, I'll do this, we're going to divide, add 1 to everything by the total, which is at the bottom right here. Close that off. Let's see, what did I do? I think I added a parenthesis, a straight parenthesis. So we did that. So the next thing we want to do is the probability of the token, given that it's about an other. We'll name the column that. And again, we'll just do the natural log here. Okay, so we have our probabilities. Looks good to me. So let's go hit some test tweets. So I got 20 test tweets here, and you can see I've already classified them. So whenever you do data science, what you do is you take part of the data set, like let's say 80% of it, and you train on that. So that informs, in this case, our classifier, the probabilities. And then you test it with the other 20%. So you take 80% train, test with 20%, just to see how it does. And if you feel good, you can go deploy it. So we have some tweets that we're testing here, and we have already labeled them. That means we already know what class they belong to. Labeling data is the hardest, worst thing in the world. So don't take it for granted that we've already done all this. I've just made your life easier. So what we want to do is we want to run it through our classifier, and if it does a good job, it should predict whether it's an app or another. So I have done us all a favor here, and rather than go through Power Query again, I already have our tweets tokenized and prepped, okay? So we're already here. So what we need to do then is compare the probabilities of which class it's going to be in. So I'm going to say probability, it's an app. This is not exactly right. I mean, I should say given or whatever, but I'm just going to skip that right now. So I'll say probability other, like that. And in this case, we're going to use X lookup. So we're going to look up this one over in our about mandrill token. So we're going to look that up on this last, or wait, no, we're going to look it up. We got to look it up in this column. We're going to look it up here, but we don't want to have it on all. We don't want all the headers. Let me do that one more time. What am I missing here? I hate that I just am doing this. Bring this back here. Okay, I'm just going to edit it in here and make my life a lot easier. Okay, so we want to look this up on the tweet like that. So we're going to look it up, and then we are going to return the final probability using the natural log. Okay, so I'll hit enter here, and what I want to do on this is we're going to make my life easier by. I gotcha. We'll get there. Okay. Like that. Like that. Okay. So we have it. This is going to look it up, but we still have one problem, because what if there's a word in here that is not within our data set? So what do we need to do? So we're just going to actually force it in this case on our on the if not found. We're going to just say take the natural log of 1 divided by, in this case, the entire total. So this is we're basically adding 1 to that word, because it doesn't really exist in our data set, but we're going to pretend like it does. So we'll hit enter on that, and then what we're going to do is we're going to basically do the same thing over here in terms of the other ones. So I'm going to say X lookup like this, and to keep myself organized, I'm going to lay it out nicely. So we're going to look this up, and where are we going to look it up? We are going to look it up in the About Other Tokens under this one right here. I'm going to move fast because I know we're going to run out of time here. So we're going to look this up over here, Alt-Enter, and then we're going to return this column over here, do a comma. If it doesn't find it, we want to take the natural log of 1 over, add 1 to everything. Okay. Alt-Enter, close that off. You are missing a parenthesis. All right, there we go. We have this part set up. So last thing we need to do here is I'm just going to use a pivot table. Of course, you could use formulas for this, but I think a pivot table is easier. When I wrote the book, I wasn't sure that everyone would have the new formulas, so you could definitely use a formula here. So I'm going to put the number in the rows like that, and then I'm going to put the class here. Well, let's see if we can switch that around like that. So we have our tweets. Then I'm going to put the mandrill one over here, so it's going to take the sum of it. And so when you look at these, whichever one is greater is is the correct one. Now, I don't actually like using calculated fields, but I'm going to use one in this case just to make my life easier. Of course, you could look at this and do that work yourself. But what I'm going to do is I'm going to go to Pivot Table Analyze and click on Calculated Field. And I'm just going to add a model prediction field. And we're going to use a simple if. If this here is greater, this is our rule, than that, then return a 1, otherwise return a 0. So I'll hit OK. And as I look at this, here's how it classifies. So if it classifies as a 1, it's predicting that it's an app. If it classifies as a 0, it predicts it's other. So we know in this first set, these are all apps, so it looks like it only misclassified 1. And then if I go to this second one here, these are all others, it only misclassifies 1 as well. So this is how you build a spam detector in Excel. This is how the spam detectors work. Congratulations, you're all data scientists. All right. Now, as I'm finishing up here, as a reminder, these are the books. Follow me on LinkedIn, okay? I do a lot on LinkedIn. This is the best way to connect with me. The other thing is I'm growing my Instagram this year as I am becoming I am a digital nomad, but I'm building up that side of my business. And so if you guys like Instagram and you want to connect more personally, not all about business, and see that my other obsessions like hot dogs and grilled cheese, you can find that at Jordan Goldmeyer. Happy to connect with you. And with that, I appreciate your time, and I open the floor to questions.
Thanks, Jordan. Questions for Jordan? Who's first?
It's okay. They're in awe. They're in awe, you know?
Probably. No questions?
Well, you know, you should never call a statistician's work average. It's mean. And before I end that, I just want to say, okay, so I forgot to say this one. The pivot table walks into a bar, okay? Bartender says, hey, can I start a new tab, right? Well, that's better than, you know, the database engineer who walked in the bar and tried to join a random table. And of course, there was the person who had so many beers, they just had one too many, you know? All right, and with that...
Give a big round of applause for Jordan Goldmeyer.